Okay, so here we have the next question on the menu today, which is some trigonomic stuff. Okay, so the question is asking us, we have to find the exact value of sine squared of theta and 2 cos of theta and 1/2 sine theta. Uh, all of these evaluated given theta equals 60. Okay, so maybe we could draw a triangle for this. This could help us visualize what is going on. It seems that I don't have a tool to automatically draw a right angle triangle, so I got to do it by hand. So, you know, if you're a nice person, you will pretend that these lines are perfectly straight and triangular, like this. Okay, and imagine, so we have this 60-degree angle, right? And we know that, hey, if we were to double this as a equilateral triangle, oops. Okay, so let's say we started off with this equilateral triangle and we cut it off. Let's say the equilateral was 2 here, 1. This has a distance of 1, and this right here, this will be root 2 squared minus 1 squared, which is equal to root 3. And that is from the power of Pythagoras' theorem that we calculated this length right here. Okay, so given that we know that equilateral triangles have 60 degrees everywhere, we know that this angle down here, this got to be 60 degrees. Up there got to be 60 degrees as well. And over here, well, we had 60 degrees, but we're cutting that in half, so that's going to be 30 degrees and 30 degrees. And here we got right angles. Okay, so we got 2 right angles attached together. They make an equilateral triangle, and given this, we can actually find out a lot of the stuff with the power of SOHCAHTOA. Okay, so let's look at this 60-degree angle right here on the bottom. This side length here is going to be 2. Just write that explicitly. Okay, so the first one we know is going to be, let's talk about A, which is sine squared of theta. If you're unfamiliar with this squared notation, another way that we can write this is sine theta, and we square that whole thing, or sine theta times sine theta. Okay, so that's fairly straightforward. Hopefully it could be fairly clear that to handle this situation, we just have to find the sine of theta and then multiply by itself. So looking at here, we know that SOHCAHTOA, we know that sine theta is equal to opposite over hypotenuse. Okay, so if this is the angle that we're looking at, the opposite is going to be over here, right? Because it's opposite to the angle, and the hypotenuse is going to be the 2. The hypotenuse, well, that's just the way that it's got to be, so it's going to be root 3 over 2. Okay, and this is equal to sine 60 degrees, and 60 is our theta. I'll write that super clearly. Okay, so given this, let's sub this into our equation here. So for our case, we have sine 60 times sine 60 degrees once again. And we know that sine 60 is equal to root 3 over 2 times root 3 over 2. Now if we continue with this expression, we could see that root 3 on the top multiplied by root 3, that's just going to be a regular 3. The roots neutralize each other. So that's just going to be regular 3 over the bottom, which is going to be 2 times 2, 4. So 3/4 is going to be sine squared of 60 degrees, or 0.75. Another perfectly valid way to write that, and this is sine squared of 60 degrees. Oh, you couldn't see that. Okay. Okay, this is the math. Yeah, cool. So I'm going to just move this ASAP fast. Whoa. Okay, move you real fast. Okay, like this. Okay, so hopefully we came to 3/4. Yep, perfect. Okay, so now let's take a look at B. Oops, let's get our pen back. Part B, which is asking us 2 times cos theta, which is 60 degrees. Okay, so looking at our SOHCAHTOA breakdown, if we look at this 60-degree angle, we know that cos theta shall be adjacent over hypotenuse. In this case, the adjacent is 1, adjacent to the angle. Hopefully that's you can see that. And the hypotenuse, well, hypotenuse is always going to be 2, so let's write this out. So cos 60 degrees is going to be the adjacent of 1 divided by 2. Awesome. And given that, we can substitute this into here. So we'll have 2 times 1 over 2. And with some quick math, 2 halves makes 1. Okay, so this will be B. Is that the answer that we got? I hope so. And yep, precisely right. Now that's B. Now the last one that we got is sine, or 1/2 of sine theta. (60 degrees in this case). And as we've seen from up here, we know that sine 60 degrees is going to be √3/2, so we can just immediately sub that in. 1/2 times √3/2. And, well, with some quick math later, we can see that this is just going to be √3/2 times 2, that's 4. And that will be the answer to 1/2 sine 60. Okay, hopefully we came to the same conclusion here, precisely the same conclusion here. That's awesome. And we can call it a day on this question. Everything is good. Okay, so just keep in mind, this equilateral triangle is like a very, very useful thing to keep in mind, because you can always get your 60 degrees and your 40-degree angles, and you know, you can extract it from here, and it's easier, in my opinion, to memorize this triangle than it is to try to memorize like all of these ratios individually. Okay, so that's just my suggestion. But otherwise, you know, whatever value you like, you'll find it like this. It's also perfectly reasonable to do it with a calculator, but sometimes on your test, you may be instructed to show this graphically, because you know, that shows a deeper mathematical understanding, and that's what typically what tests are trying to look for. Okay, so here the above solution is good. Good job. Big high five.